Hey guys, welcome to my channel. So this is my first video on Jmeter, but before we hop on the tool, I must tell you some basics of performance testing because I think that is also an important part that you should know some basic jargons before we start learning the tool. So let's hop on the PPT first. So in this performance testing PPT, we'll be learning introduction, performance testing basics, performance engineering basics, performance testing methodologies, typical performance testing tools, and bottleneck analysis. So at the end of the session, you will be able to appreciate the basic performance testing life cycles, the standard performance testing tool, and how to identify and analyze the bottlenecks. So there was a site called POMS, a very good music download service for the users. But there was a new song called Ketchup Song, which was uploaded on POMS website, and it was not famous initially, but after some time it became a huge hit, and the video was aired on TV channels, and it got never seen popularity. So just in a week, the Catcher song was downloaded by around thousands and thousands of time, which actually resulted in the crash of PMS. Why it got crashed? Because they didn't analyze that much traffic on their website, and they just assumed that if this much load is running well, then the maximum load of, let's say, 1,000 or whatever they have decided will also run fine. So we never go on assumptions in performance testing. That's the learning from there. And this is some example where a Dell website got crashed due to the same issue because they didn't analyze the traffic. And when Christmas came, there was a huge load on the site which crashed them. So same example with a high street bank who was lagging due to that load. So these are some basic examples where industries lost their money, lost their business due to performance testing negligence, you can say. Performance testing, if I say what is this? So performance testing is a discipline concerned with determining and reporting the current performance of a software application when subjected to a virtual user load. If I talk about virtual user load, that is something which is generated by a machine. That is not which is something which is generated by a human being, because you cannot make 1,000 people or 100 people sit together and perform a same action at the same time. So performance testing is a critical component of application overall success. It prevents product failures by predicting the application behavior and capacity before going to live. Before any application go live, we test it thoroughly to make sure that we have tested it with a very necessary amount of load, you can say, so that it may perform on those scenarios where a fluctuating load can come. Performance testing measures three things. We measure speed, we see how much scalable it is, and how much stable that application is. So in terms of speed, if I say speed, that means how much quickly that application responds. If I say scalability, that means how much more user load we can put and how much more user load it can handle. And stability is basically where you determine the application either is stable under varying loads. Under varying loads means when we put at different type of load at different time. So in performance testing, we give more emphasis on understanding critical business flows. That means we will not cover those things which are just kind of text change or database changes or drop down things. So we don't those changes because that is something which is taken care by functional team. So but also we must know the detailed architecture of the application, because to judge something better, to judge your application better, you must know what the architecture is behind. So also usage patterns and volumes. So if I talk about usage patterns, that you must know how much your end user is using your application. Let's say if I talk about Flipkart, let's say in the morning it may have very least load, but in the evening when people are free, they are going to that portal and they start shopping. So that is something usage pattern, because in morning, let's say, it is having less load, and in evening it is having more load. So that usage patterns is something where we analyze that how much load is coming at what time, and also at which critical flows. That means at which functionality. Let's say if I say that everyone is logging in on Flipkart and then everyone is checking out, so these are some critical business flows where we'll put maximum load. Functionality and other system parameters needs to be tested for performance, hence non-functional requirement also needs to be gathered. So it's not like we must only see the functional requirements, we must also see the non-functional requirements like security, firewalls, or all these things you must know. And also the background process, any batch jobs which is running on the back. any shared services which are using your server, you must know all these things before you start doing a performance testing on an application. So also you should know the application usage growth, because you cannot perform performance testing every week or every month. So when you say that this performance testing is done for this quarter, you must know that what is the usage growth, that is how much your business is growing every week or every month. This data can be collected from a database or from the past analysis. So you must do these things before you do performance testing. So why we do performance testing is basically three objectives: or determining the application performance at various user loads, identifying performance bottlenecks, and performance benchmarking. So the question arises, either bottleneck is same as failure. So no, it's not same. Bottleneck is where your application is responding, but it is responding very slowly. But failure is something where your application is failed, it is not responding at all. So these are different types of performance testing: load testing, stress testing, endurance testing, volume testing, scalability testing, and availability testing. So if I talk about load testing, we simulate a real-time user load which is done on application. So let's say your business says that you have to test this application with 100 user load. That means when you are running a load of 100 users, that is your load testing. When you are running more than 100 users, it comes into stress testing, where you are stressing your application. So the difference between load and stress is basically when you run with the defined load is a load testing. When you go beyond your defined load, that is stress testing. So now endurance testing. Endurance testing is basically where we test our application for a longer period. We test the same load for, let's say, 8 hours or 10 hours to see the memory leaks. Then volume testing is basically done on database to see the database behavior, to see how much fast your database is responding. Then scalability testing is basically to determine how much we can expand and how much your system will accommodate with the increasing load. So the question arises, what is the difference between stress testing and scalability testing? So basically in stress testing, our main motive is to crash the application, to see where my application is crashing. But in scalability, it is something where we are just doing the test to see how much scalable my application is. We are not uh, doing this test to crash your system, but we are doing it in this test to see the scalability of application. Now this is availability testing, where we test how much available is your application to collect the failures and all the repair times, to see that how much the downtime is. Okay. So if we are done with the performance testing, we actually gather some performance matrices. The basic performance matrices which we gather is response time, throughput, CPU utilization, memory utilization, load size, and think time. So response time is basically at the time interval between the requests going and response coming. So once you submit some button or anything which what action you perform, it sends some request to the server, and as soon as you get the response, the time difference between request and response is called the response time. Throughput, it is a rate at which computer or network receives the data from a server. So it is calculated in bytes per second. So whenever you click on submit, that what happens? It sends some data and it receives some data from the server. So that sending a data and receiving it is called a throughput, and it is calculated in bytes per second. CPU utilization is basically what you see whenever you run an application, whenever you hit some services, you actually send to something to a system and it utilizes some memory. So that we actually monitor that how much CPU is using, how much CPU usage is done on the application. Memory utilization is basically to measure how much available your RAM is, what is the available memory, what is the physical memory. All these things you can gather in this memory utilization. Load size is basically the number of concurrent user load. That means you are running, let's say, with 1,000 user load. That means 1,000 is your concurrent user load. But concurrency means running multiple users on the same action at the same time. Okay. The think time is basically the time taken between the user to think between two consecutive requests. If I explain it more, think time is basically the time taken by a user on a application. For example, if I record a script of, let's say, login login, and then selecting a product, and then checking out. These are three scripts, right? So if I run this script in my Jmeter, it will run in seconds. So, but ideally, this is not a situation. When a user comes to a page, it thinks for some time. He thinks for some time, and uh, then he decides actually what he wants to do. Let's say he's going to login page, then he'll wait for 1 or 2 seconds, then he'll log in. After submit button, he will go to the page, he will look for some products or all those things what he wants to buy, let's say. Then he'll add them to cart, then he'll click on the cart, and then he'll check out. So this whole process will take somewhere around 30-40 seconds, but it if I talk about Jmeter, it will only take 3 to 4 seconds. So that is the basic thing for which we give this think time, so that we can simulate the ideal usage, how a real user performs. So also we need to gather some system level parameters, like what is the OS, either it is Unix based machine, it's a Windows based machine. So if it's a Windows based machine, you can get all these stats from performon. If it's a Unix based machine, you can get these stuff from IOStat and VMstat. So then we also gather some database specific parameters, like response time, server time, network time. All these things can be gathered from database. That is a different part. That is a call that comes in the engineering part. This is something a kind of graph which we get on performon. If you don't know how to get the performon graph, you can go to your Windows and click on Windows R, type performon and hit enter. It will open up performance monitor page, where you can see all these things running, that how much CPU is utilizing, how much memory is left. So if you want to add some graphs, you can see there will be an add button, and you can add those things which you want to analyze. These are some factors which we decide, which we consider while we select any performance testing tool, because every tool has some limitations, and every tool has some uh, pros and cons. So let's say if I talk about Jmeter is used basically for web test, to test some HTTP response or FTP or something. It is not ideal for testing some desktop based applications. So before we select a tool, we must know some basic things, that what this tool can do, what are some limitations. So before selecting a tool, you should know what it can perform, like either it is easy to use, efficient data collection, protocol support is there or not, how much protocol support it does. Protocol means is either supports for HTTP, FTP, database, LDAP, all these protocols, either it is supporting or not. Then how much scripting effort is needed, how much is the license cost, how much you have to invest on that tool. Either it is able to do automatic data generations, addition of transaction level timers, ability to add checkpoints, user ramp up, load control, all these things which are listed here, you must know before you start to select a tool. So what issues we evaluate while doing performance testing are throughput, rate at which the computer or network receives the data, number of users working on the same transaction, that means concurrent users, usage of resource and at a particular instance of time, that means how much memory, how much RAM, how much hard disk, all these things are utilized. Then the response time, that how fast your response is coming. So these four parameters you will first see. When you see any issue, you will go to your response time, you will check that, you will go to your throughput, you will check that where the issue is. So with this, I am at the end of the first slide. So after that, we will learn something about performance engineering. So that is a different part of performance testing. What performance engineering is basically where we evaluate the issue and where we try to fix those issues. In performance testing, we basically test the software. In performance engineering, we assess the software and we find out the problematic areas. So in next video, I'll tell you some performance engineering basics, and then we'll start with Jmeter. Thank you. Thanks for watching. Bye bye.